Today we're going to be talking, I'm just kidding. So when you think of an equal sign, you think of two sides, right? Two sides that equal one another. And what object or what illustration helps you to think of two things being equal?
A balance beam.
A balance beam, right? I actually remember in elementary looking at balance beams, like putting things on both sides and seeing how they get affected. In our cases, we always want to do the same thing to both sides because we always want to be balanced, like always. And this is another way we're going to do it. So please write down this equation. 2 times the quantity n plus 10 equals 40. Okay, so this is an equation, has an equal sign, and what we're saying is that this side right here, this left quantity expression, is equal to that expression over there, 40. So whatever this is, it's worth 40 because that side is worth 40. Okay, so what I want you to do is maybe tell me what you would do to solve this equation. So what's our goal when solving equations? What are we trying to do? What are we trying to find? Right, Grace?
Find the variable.
I want to know what that is equal to, right? I want to know what that's worth. And some of you could probably do this, you're like working on your head. Got it, which is cool, but not all of them are that easily found. So what would you do first? Sorry, I had like 3 hands. Anybody? What would you do first? I like this because you could do multiple things. Hopefully you do them right. Yes, sir. Okay, you're going to distribute. So you have a number being multiplied by a quantity that's being added or subtracted. So yeah, I'm going to distribute. So 2 times n? 2n. 2 times 10? 20. And that's still equal to 40. These are equivalent equations. They're worth the same thing. Okay, so what would you do next? This is what I think of, guys, when I'm solving an equation. I look at the variable. I found it. It's right here. Is it in one spot? Is it in one spot? Yeah, it's right there. So then I ask what's happening to that variable. First, it's being
Multiplied by 2.
and then
20.
added with 20. Okay, so how do I undo that? Yes, sir, Nelson.
Subtract 20 from both sides.
Yes, subtract 20 from both sides. 2n equals 20. Okay, and then what's still happening to n? It's being multiplied by 2, so I should divide both sides by 2, and I'll get my n equals 10. Now, that's my solution. I think n equals 10, and like on any quiz or test, oh, by the way, how many of you checked your answers on that quiz? Okay, how many of you know you got some of them right? Like you're like, I checked it, it has to be right, it has to work. How many of you tried to check it but still weren't sure? Because yeah, that's all right. But hopefully it helped you out a little bit. So there was still some of that. Does this check?
Yes.
All right, what's 10 plus 10? 20 times 2. So it is n is equal to 10. So we're good with that. Yes, sir.
If on homework, if we can do it in our head.
No.
But we can check every problem.
No, you don't have to check every problem. You can, but the question was, do we have to show the steps? Yes, do it. Thank you for asking. Okay, let's do another one here.
But Mr. A, what if you distributed and n equals 10? It would be n times, or 2 times n is 20. 2 times 10. Wait, never mind.
Isn't it cool how it worked? You're like, oh yeah. Actually, you know what? 2 times n plus 10. Rewrite the problem. Rewrite it, yes. Do it again. Okay. Just to show you that in algebra, there are many ways to do it. In fact, the next problem I'll try to do it like 4 ways, okay? I'll try to do 4 ways. And then the following problem, I want you to come up with a way that's unique but correct. So you can come up with a unique way of doing it wrong or incorrectly, but that's not helpful. Okay, look at this right here, guys. What's happening to n? Just looking at it right here. First it's being added with 10, then multiplied by 2. Do you see how that's a little different from that last problem we did? Yes, first it's being multiplied by 2, then added with 10. Now we switch things up. But that's what it says. Okay, so what would I have to do first to undo what's going on here? Justin?
Are we giving the special way?
And we're just doing another way. Because you could do it this other way too.
We divide it both sides by 2.
Okay, you're going to divide both sides by 2. Both sides by 2, right? These 2's cancel each other out. You're left with n plus 10 equals 20. And then what would you do to both sides? Subtract 10 from both sides, you get n equals 10. And that is the answer. So was there only one way to do this problem?
No.
Absolutely not. In fact, if you really want to get technical, there are many, many ways to do the same problem. Just keep moving things around as long as you're allowed to do it. Okay, did you guys get that one? So do you have to distribute? No? Is it helpful sometimes to distribute? Yeah, I would say so. But it just depends on the problem. Yes, sir. Regardless of the way you do it, I need to see what you did. I'm like, you got from here to here. I'm like, cool. What'd you do? Well, I just did that method. What method? Well, when you just, do that, this, and then that. Both sides. Don't forget. I'm like, I don't know what you did. Justify it. Boom. It's justified.
But you got the right answer, and that's all that you need.
No. Again, so the right answer is good, right? I want the right answer. But I want to know how you got it because you communicate. You're at a business meeting and you present the numbers. You're like, see, we're going to make a 5% growth in profit. Awesome. Can we see how you got that? Well, I just did in my head.
Are you talking about Shark Tank?
No, yeah. Yeah, and they do it all in teeth. They're going to show you all the details, but when they look at the paperwork, where's your work, buddy? Well, it's going to be 5. It's like about 5%, okay? Show it to me. You want to introduce a new drug on the market to help people who struggle with, let's go with migraines. So you you develop this new drug. It works for this person. Can you show me the data? I just kind of did it in my head. Well, literally, I did it in my head, right? I took the pill. And see, they're going to say, no, we can't use this good thing because you don't have data to back it up. So use the data. I'm scared for you.
Mr. A, if you do something that the computer does the work, so all you do is enter a few numbers and then do it.
We're thankful for the computer who did the work and the people who made the computer do the work, which you could do. Okay. Ready to move on?
Go to Subway and you give them
Like the Subway or Subway?
Subway like food.
Gotcha.
And you give them the right money back and they say, how'd you do that? I mean, they won't say, how'd you do that? You just give them the right money.
Yeah, that's true.
Yeah.
So that means you don't need show your work.
No. That they would have to check, like they count the money, make sure it's good. Got it.
Yeah, that's true.
That's,
They know that you're right. in your
Doesn't God
head.
give you the ability to do math so that he knows the data so then you don't have to justify it because he already knows it?
does anyone's parent work in business and finance or something like that? Anyone that you know of? Somebody. Okay, ask your parent.
Who works in
What do you mean, like?
In any kind of money management, money dealing, business, trade. Yeah. Okay, you just go ask your dad. All right, I'm done. Go ask Benton. How about that?
Oh no.
He doesn't like you.
I'm never asking.
Don't worry. I still care about you guys. Are going to make you do this. All right, this one's cool because we're going to do it several ways. Okay, let me get your way first. What I'm trying to do is I'm trying to find out what Z is. What Z is, but it's not even in one spot. Z is not even in one spot. So I'm not going to start undoing things until the variable's in one spot. So I have two options. I can either get this 12Z to the right side or this 8Z to the left side. But you got to do it the right way. How can I get 12Z to the right? How can I get rid of it from the left side, get rid of it completely from the left side, and somehow get it over there to the right side? Is that possible? Yes, Angry.
Subtract 12Z over 5.
Subtract 12Z from both sides, which I'm allowed to do because of the subtraction property of equality. You're allowed to take away the same amount from both sides, and I did. So I get rid of it here. I get negative 3 equals negative 4Z plus 13. All right, then you can solve it, right? Go ahead and solve it. You go ahead and do it because I'm going to do it again a different way.
Can we do
Papa.
it?
You can do it another way, but just solve it this way. We'll do it another way. Awesome. Then wait.
Wait,
Yeah, just wait a little bit if you've already done it.
What if you already did?
Awesome. Any other questions? Don't want to leave anyone behind here. Okay. This might not go online. Okay. You got your answer. I'm going to leave it alone. I'm not going to say anything about the answer yet. Go ahead and rewrite it again. Rewrite that problem again. And you won't have to do this on every problem, but rewrite it. Rewrite the problem. Beginning now. Okay. The first thing we did on that last problem was we subtracted 12z from both sides. How can I get rid of the variable from the right side and get it only to the left side?
Subtract 8z.
So go ahead and do that, guys. I want you to do that again. So I'm allowed to do that because of the what property of equality? Subtraction property. I'm allowed to take away from both sides. So I get 4z minus 3 equals 13. Now, last time I got negative 4z over there, and now I got positive 4z over here. I trust that.
If you subtract 3 from both sides, you get, or you add 3 to both sides, you get 4z equals 16.
Write this somewhere on your.
And then you divide 4 and then.
This is something I taught last year, a little bit later on, but write this down, guys, in your notes somewhere. Change side. Change signs. Change side, change signs. For those who don't like showing work, want to make it a little bit easier on yourself, you could do this. I'll show you what to do right now. Okay, I'm just going to write, this is a separate equation just to show you this again. Let's go with x plus 12 equals 37. Okay, if I wanted to make the x go over there, what would I have to do to both sides? Subtract 1x, right? Subtract x. And what would it become over here? What happens when what do I get over here with the x? I get negative x, right? So I got eliminated here. It became negative x. Do you notice I didn't say to subtract x from both sides? Like I didn't write that down. Because what happens when I change the side of a term? Like if I move it to the other side, I have to do what to the sign? What if I want to move this guy over to the left? So you add x, so all I get is x plus 12 equals 37. These are both the same thing. What if I want to move that 12 over to the other side? Can I do that? Yeah. I can get rid of it here, and it becomes negative 12 over there, right? That's change side, change signs. That's nice. That's very...
They should make a song about that.
There is a song. I just can't sing it right now. And even if I did, even if I could, I wouldn't. Okay, anyway. Did you guys solve it this way? The second way? All right. The third way.
What? There's 3 ways.
If I wanted to get this negative 3 out of the way, could I do it?
Yeah.
What would I do? So instead of dealing with the variable first, I'm going to deal with the negative 3. So I'm going to end up with, boys, 12z equals 8z plus 16. And then, and see, from here you can branch off to 2 separate ways, but what would you do naturally? Yeah, you're going to get rid of this 8z from both sides. So you subtract 8z from both sides. 4z equals 16. On any of those answers, did you get z equals 4?
Yes, sir.
So all 3 of the ways we've done it now, right? Is that the only way to do this problem?
There's many more ways.
Okay, here's the challenge. On the next problem I give you, I want you to come up with the most unique way of working out the problem correctly, though. Like, you can't just say, oh, see, if I work, I got z equals 12. Well, that's wrong, even though you did it in a unique way. It needs to be correct and unique. If you, how about this? If yours is the most unique, you can show us all your creativity. Go which creativity in math is very, very important. Okay, here we go, guys. Yeah.
Are you in the competition for the most unique method?
I am not, because yeah, I would come up with one that's really random, and no, I want you guys to do it. Random, but
Can it just be longer?
it could be longer, yeah.
9 billion, will you give us?
But yeah, so you don't do this like you subtract 6v, add 6v, subtract, just keep going back and forth. Just do it. Yeah, we'll see how it goes. Don't make it redundant. That means don't make it like, see, I just kept subtracting and adding 4 from both sides 5 times, then I solved it. No, that's just messed up. So once you guys get your unique way, I'll do my unique way. How about that? I'll do what I could have done, and you tell me if I'm right or wrong. And it's a longer way. That's why it's unique.
Is there like an algorithm?
Just you'll see you'll be able to tell me everything I'm allowed to do, or why I'm allowed to do everything I did, I should say.
Is there math algorithms?
Yeah, like when you multiply 2-digit numbers, you're using an algorithm. When you divide, where you do the long division is an algorithm.
They were used with computers.
No.
Yes.
Yeah?
They're computer algorithms.
Yeah.
Yeah, but they're used for math.
Yep.
More.
Yes.
Well, technically, on the computer, you're doing math, so.
No, not if you're playing Snake Game.
Okay.
All right, I'm going to give you 30 seconds. This is breaking down very quickly. All right, here's what I would do, and this is just one way to do it. First, I'm going to subtract v from both sides. So I get 6v plus 9 equals 4 minus 4v. Then I'll subtract 6v from both sides. So I get 9 equals 4 minus 10v. Then I'll subtract 4 from both sides. 5 equals negative 10v. Then I'll divide by negative 10, and I get v equals negative 1/2. Because you got to make sure it's reduced. Don't worry about fractions. Don't be scared by fractions. Did you guys get negative 1/2?
Yep.
Okay. Okay, negative 0.5 is okay. So you got that answer. Did anyone do it like this? Yay, I win. No. Okay.
Negative 0.5, is that good?
Sorry?
Is negative 0.5 good?
Yeah, negative 0.5. All right, this is how I'll do a trial run. Look at the person to the right, to the left, in front, and behind if they're around, and see if you guys did the same way. If you did the same way, you're eliminated.
What if I did it your way?
We're eliminated.
Bro, the weirdest way to do
So you guys are competing right now. Let's see who got it. Did you ask people all around you? All around you? Okay, listen up. I'm going to ask you a question. How many of you did not do it like anyone around you so far? You haven't done it like, you did it just differently. Oh, wait, keep your hand up. 1, 2, 3, 4, 5. 5 of you. Oh, I thought more. Okay, cool. Hey, 5 of you. Henry, who was it? Jack, Henry, Anna Grace, Elijah, William. Who was over here? Go check each other right now. Go. Look at each other. You're 5, 4. Uh-oh. Oh.
I think you should throw it out like a ball. I think that should get a ball.
Okay, go ahead and sit down. I'll ask you a question in just a moment. Okay. Let me work it out one other way and see if I eliminate one of those 5. Did anyone, your first step was you added these 2 together?
Yes.
7v plus 9 equals 4 minus 3v. And then you added 3. How many of you added 3v next? This is what you did. You did. So some of you did not do it fine. And then you subtracted 9 from both sides. Anyone still there? You did exactly like I'm doing it here. Keep your hand up. All right, keep it up. And then you get 10v equals negative 5. You divide both sides, you get v equals negative 1/2 or 0.5. How many of you did it that way? Ooh, we all think alike, don't we? Okay. Yeah. Okay, good job. Did anyone not get negative 1/2 or negative 0.5? You did not get. That is unique and unique as well. Did you guys determine who was unique? No.
I don't know.
Did you guys do it like I did so far?
No.
All right, who wants to come up? 1? Do you want to come up? No? All right, you want to come up? Jack? Jack, come on up. You have to show the work so that we can justify it. All right, listen up. As Jack is working it out, I'm going to call on each of you, or as many as I can, to tell me what he did to get to that next step. So Jack, you go ahead, go with your first step. He's not going to answer, I will. So don't say anything, guys, until I call on you, and the first person I'll call on is Philip. All right, the first person I'll call on is Gracie. How do you do that first step? And what's the justification for that? Yeah, you can keep going, Jack. What property?
I have no idea.
Does anyone know what property was used when you added 3v?
Property of math.
Addition, property of equality. All right. Olivia, his next step, he subtracted 4 from both sides. What property is being applied? The property of, yes, through equality, because you're doing it to both sides. Okay, then he, let me see, what he did. What did he do? Sorry, Jack, can you tell me what you did here?
So I subtracted 4 from both sides, and then that would be 9, and then I just sorry.
I saw 15. I'm sorry. No, you're good. I thought it was something else. What do you do, Drew, to go from here to here? What's the justification?
Addition, property of equality.
Nope, because he didn't add to both sides. He didn't do it from both sides.
Add like terms.
That's it. He added like terms. Boom.
3 times the term.
But yeah. What's this property right here, Henry? What do you call it? He subtracted 5 from both sides.
Subtraction property of equality.
Very nice. And then how do you divide both sides by 10? What property is being applied? I haven't mentioned it, but I hope you guys know. Subtraction property of equality, addition property of equality, division property of equality. So those are allowed, and then he gets his answer. Okay. You guys are like, Mr. A, this is too easy. Cool. Let's go to this next one. All right, how many do I have? I have 20. Am I missing 3 people? 1, 2, 3. Alex, who sits next to you? Okay, so yeah, 3. So we have 22 people. I need 20 of you to get this one right.
Only 20?
You don't have to be unique, just get it right. I want to know what M is worth. as you guys are working, I'm going to give those properties of equality. See if you can listen and work at the same time. The addition property of equality. Adding the same amount to both sides of an equation. The subtraction property of equality. Subtracting the same thing from both sides of an equation. The multiplication property of equality. Multiplying both sides by the same amount. Division property of equality. Dividing both sides by the same amount. No. Sorry, Nelson, I'm going to take you guys all at the same time. I hope you all get it right, or at least 20 of you. All right, who needs more time? I'll give you about 30 seconds if you need it. All right. Alex, come on down. Work this problem out. Any way you want, as long as you're doing the right thing. Don't worry, I'm going to call on your classmates to justify your work. Ellie, his first step, you're going to tell me what he did. Like, justify it. Which property was used?
Okay, that's like not fair.
Of equality. Okay, so that's good if he applies it well. Oh, look at that. Hold on, Alex, before you keep moving on. Okay. When he divided the left side by 2, these two canceled out. So we're left with 3m minus 1. I'm okay with that. Why did he divide the right side by 2? Why didn't he just divide 2m by 2? You have to do it to both sides. So he divided both of these, or all of the terms, by 2, which, yes, gets him m plus 1. All right, yes. Sorry, Alex, didn't mean to stress you out. All right, next one. Sophie, what property was applied next?
The distributed? Or wait.
So this step right here, he did something here. So what property is that?
Subtraction property of equality.
Okay, subtraction property of equality. Next property, Jack. Let's see what he does. You tell me if it's a property. All right, go ahead.
Addition property of equality.
Good, addition property of equality. And Matthew, the last one he's going to have to use.
Division property of equality.
Okay, I need to correct myself. Did he have to use the division property of equality? Which would have been, he could have multiplied both sides by a half. It would have been the same.
The answer's 1, not J.
No pressure. Who got m equals 1? All right, let's see. M equals 1. All right. All right, I got, raise your hand if you got m equals 1. Okay, there you go. Please, that scared me. I think we had, did you guys get m equals 1? I think we had 20 people getting it right then. So we just barely met that threshold. I don't even want to know what would have happened had that not been true.
Yeah.
Oh, sorry, I didn't mean to make that.
Oh, this is like unfair. It's not fair.
I'm sorry you misunderstood. 20 beginning right. All right, we're still good. All right. I think the most natural thing to do is to get both sides to be as simple as possible. So simplify both sides. To make the left side simplified, I'm just going to add these two terms together. That's adding like terms. And on the right side, adding like terms would get me this. Okay, then I want to get the variable on one side or the other. I'm just going to go with subtracting 8k from both sides. Please be careful how you do this because you're going to see it again. And I don't want you to get this messed up. What's 8k minus 8k? 0k, which is 0. It gets eliminated. What happens over here? It gets eliminated. 0k is 0. So what am I left with?
3 equals 3.
Okay, 3 equals 3. Did I solve for the variable? No, because there's no more variable. It's gone, right? But what's my answer then?
3.
Well, looking at this right here,
Yeah, 3.
is this a true or false statement? How about that? So I'm going to write true here for your notes. It's a true statement. That means that the solution for k, all, and I'm going to put all real numbers.
Mr. Ray, I added.
Wait, what?
Mm-hmm.
That's all real numbers.
How many of you said 3 was an answer? How many said 3 was an answer? That's true. How many of you said 0 was an answer? How many of you said that 10 was an answer? Negative 15 is an answer. 1/3, 2/5.
So if it's the same k on each side, you can go.
I added 2.
Wait, so Mr.
If you end up with a true statement at the end, any number fits for k. Any number. And it still makes it a true equation.
I have a question. So,
Yes, I have 5.
so,
Yep.
so if it's all real numbers, you can't use like over and negative.
Yes. Yeah, no imaginary numbers. Yes.
To get rid of -2, I added 2 to 5,
Uh-huh.
and then I got 7 plus 8k. And then
Oh, sorry, these right here? Oh, okay, remember, this is positive 5, that's negative 2, and the only way to combine those would get me 3.
So would pi be a correct answer for that?
Pi could work, yeah, it's irrational, and therefore real.
Wait,
Which
what's
is
a
good.
not real number again?
The square root of a negative number. You can't get that. Yeah, it's too bad. Oh, thank you very much. Good news. Okay, guys, that's the first exception. Negative 3y. Let's work this one out.
Is this the last one?
It's possible.
So now,
All right, you go ahead and work this one out. So in that last problem, k could be any real number. So basically any solution for the numbers that we know about. Now notice on my last problem, on my last problem, the answer was all real numbers. Not true, not 3 equals 3. My answer was all real numbers. That's what I put. On this one, make sure you give me an educated guess. You may not know what it is, but we'll figure it out right now. Okay, I haven't called on a lot of people yet. I'll go with Dylan. What'd you do here first?
I did -2y on the sides.
Okay, minus 2y from both sides.
So you get
Did you do it from which one?
-3.
All right, you get negative 5y plus 7 plus 5y equals negative 11. Okay, next.
You do -5y plus 5y.
So added like terms and you get
0y.
0y. Gets canceled out. I get 7 equals negative 11. Okay, that's all I'm left with. Did I solve for the variable? Variable's gone. Is that a true or false statement? It's a false statement.
I got 0 equals -18.
So what's your answer? Anyone have an estimate? Anyone have a guess?
Could you put 0 equals -18?
Yeah, because if you subtracted 7 from both sides, you would have gotten 0 equals negative 18. Or 18 equals 0. Technically, you could also gotten that. Or, yeah. Yeah, positive 18 equals 0. Because change side, change signs. But all of these are going to be?
False.
And so what did you think was your answer? What did you put as your answer? It's my favorite symbol. One of my favorite symbols. No solution. There's nothing that goes in that.
Is that the same thing?
No solution. Yeah. Sorry.
I put no real solution.
Put no solution. Because I think imaginary numbers may work. I don't know. Actually, I don't know. I can't say that. But sorry. How many of you saw in your, yeah, you can say no solution. How many of you saw in your homework in previous nights, they keep having these braces in their answers? You guys notice that? When you put a brace with nothing in it, you know what it means? There's no solution. There's nothing that goes in there. This is a no solution symbol. This is a null set. That means there's no solution in one another way. Or you can write out the words, no solution. So any one of those is valid. That's if you get a false statement at the end. So you know what? This equation, whether by negligence or by, this is what they wanted. I guess they contrived it. It's actually not even a true equation. So are all equations true? No. So you have to be able to determine that. That's how you get your no solution. All right, let's see my time. Oh, man. Is it that time? For homework, I'm going to have you guys do 2 through 10 all. 2 through 10 all.
Only 2 through 10? I heard it's word problems. Oh, yeah.
Yes, we're going to talk about word problems today, so hang on for that.
Oh, Mr. Ray, I have the homework from home.
Okay, I'll take that. Is your name on it? That's vouching. Thank you. Bye-bye, Swivl. Hope there's no glare for Jack.